Thank you. Thank you for the presentation. One little issue, my pizza, it's not arrived yet, but I hope it's coming very soon. Well, today my little talk is about how functional programming helps us to develop software. In the agenda is a little presentation about me, the objectives of the talk. What is functional programming? What is important, the functional programming in C++? Some C++20 features that help us to develop a better functional programming, and some correspondences between Haskell, the main language programming in functional programming, and how we can apply the concept of Haskell in C++. We finished with the little Q&A, and I hope you enjoyed this talk. Well, I don't have any more to say about the presentation. It's me, that is me. I have one picture once on time, so I use it in every social media. I am from Córdoba, Argentina, and currently I'm working at Wazuh and teach in the UNSC. What is the objective of the talk? How we can apply the lesson of Haskell, the most popular functional programming language used for teaching, for example, to the modern C++ code and improve the capabilities of code development. Some functional features of C++20, the main standard, and that introduce new ways to increase the functional weight of programming in C++. And so best practice in order to apply in the design of software. The first thing is coming on mind about functional programming is functors, monads, modals. And maybe you'll say it's a lot of mathematician. But this idea of flow of thinking, the functional programming, is based in one concept, pure functions. In pure function, we are saying that the function has no side effects. That is a function that only makes one thing and only one thing, and not produce any other result, like, for example, modifying a variable, setting a field, or making an I/O operation. The focus of the functional programming is in how we write the programs and not in details of how we implement a program. Yes? It's more focused in what we want, not how we want. And we can see two main focus of paradigms in the programming language, the imperative, and when we express directly how we can solve the problem, and the declarative paradigm that focus on what want to solve. And functional programming is form of the declarative way. It's composed by the style of writing, the functional thinking, and the functional concepts. We have here a better description and definition of what is functional programming and why it's important in C++. In C++ was born like a object-oriented programming in the first releases with C with classes, later evolved, adding new ways of programming paradigm. But the main concept is generic programming. Yes, we using templates, for example. The last standard is introduced a new way to develop C++, writing program with a functional state much easier. And I consider myself that the last standard 20 introduced a lot of concepts similar to Haskell. For example, concepts, how we can put some constraints when we're using templates in order to treat that templates arguments like types in a very similar way to Haskell do it with data types. This is done by the new keyword requires and concepts and are time compile predicates. It's important notice that we are not using runtime, we are using compile time operations. Another important feature is the user range and view using a safe iterator and avoiding copies. And how we can iterate in a way to specify a sentinel, a condition that make stop the iteration, and the views that are lightweight range. Some improvements that was made for C++20 for it's for working with features and async programming that was planning for C++20, but no was made. This is a paper I make research about the source of that information. And this paper was not included in the last standard, but there is a library in the creator of this paper that implements that feature that describe. But enriched the message with the creator of this library, he told me that a new paper was made, which is this one. And we planned for C++26 in the next release. So new things are coming, and this way of working with async programming will be very useful for us. I know you enjoyed an amazing pizza, but in this example, I bring to you to see the correlation between Haskell and C++. I made a little example with a typical food from here, from Córdoba, and that is a choripán. Probably some of you know about their existence, and there is also in the image or most popular drink. I know probably you are going to enjoy the evening with a beer, but it's very famous here, the famous Fernet with Coke. And well, I hope you enjoy the examples. First of all, when we are working with Haskell, we are working with immutable data type. And is this one of the most important concepts when we're working also with functional programming? Pure functions work with immutable data types. That means data cannot change. And we are returning also an immutable data type. So, for example, to apply this concept on immutability in C++, we have the cons, the famous cons we already used. The most popular is cons alone. Later, we introduce the cons expression, and this way to express that a condition is, a variable is cons. We're using also the approach of use costness of compile time, and not applying only to a variable, it also could be applied to a function. And it's important to take advantage of the compile time. Later, we have the concise ball that only applies to a function, and this function is only called all compile time. And we have another type of cons. It's a cons init. These ways of con inits also applies for compile time to a variable. Yes, we initialize a variable in compile time. For example, when we have in Haskell a simple variable here, for example, chorizo stock, in our example of the choripan store, that variable can never change. We need to create a new variable to express a change in our logic. So we can translate this concept of Haskell immutability to C++ in this way. For example, declare a variable like its expression. We can use condicival, for example, to make an evaluation of the variable at compile time. We have here also another expression here without the out declaration. And the second part of this is this expression here. We are declaring this variable with a const initialization, and all spend stock we calculated at compile time. And this code, if we copy it to the compile explorer, for example, will work. Like I say, the concept of pure function is one of the most important and maybe the main focus of the functional programming. And the pure function is based on the referential transparency. And referential transparency is a very mathematical concept that expresses that a function always will return the same output with the same input. We are never have a different result if we have the same input for the function. So can we see this with a simple Haskell function? By default, the Haskell function complies with the reference transparency. We have a function here that receives an int in a value, a float value, and returns a float value. Haskell function can be sometimes hard to read, but we are assigning the price, the result of price, as the result of the multiplication of chorizo stock and price. We can see this concept as a pure function in C++ in a similar way that we saw the immutability concept, declaring a function that always will return the same result with the same input. Of course, we can validate this through unit testing. Yeah. But we have this use of the constness and the expression of the C++. So there are some tips that we can use to create or design pure function, and it's one of them is avoid the global state, we should not use a variable that is write or read a global state variable. Like I'll say first, a pure function is a function that not produce side effects. In such case, the I operations are considered side effects. So a pure function should not use a operation of input output using a network connection or maybe a console connection, the console screen or file operation. And trying always to use constants to avoid modification of the argument passed to a function. There is not an active way to declare a functional pure function in C++, but we can emulate the behavior of the pure function Haskell function with these tips. In Haskell, we have also function that takes as argument a function and maybe return a function. It's very hard to see, but for the functional programming, the functions are another type of variable. So we can pass a function as argument and return a function as a return value. And this is made by, for example, here, this function applied twice receives an argument, a function that receives an int and produce an int. This is the argument f, the function. Another argument of my function applied twice is another int, and the final result is an int. And the signature of the call is applied twice f. We have here a little example of function increment takes an int and results an int value and increments the value in 1. If we assign the result of calling applied twice with the arguments of increment, which is our function that takes an int and returns an int, and the second argument in int value, we are stored in result a value 7. We can explain this concept of higher order function in C++ with the function here and the lambdas, very famous the lambdas, in order to store in a variable a function and try to use the variable like an object. Here we have the applied twice the same function before, but this argument takes a constant function, which argument of return is int, and argument of type of argument is int by reference, and another int value, and we use the same signature applied twice the f function, and we use here the increase stock, which is function that the compiler will deduce the return time that receives an argument of type int and increase by 10 units. Another way to, sorry, little sensitive mouse. Another way to use the same behavior and not declare a function in a no code is using a lambda. The new standard allows us to use templates inside of the lambda. It is standard 20 of C++, and the result is the same. We are passing to our function another function as an argument of type int, for example. In the functional programming, the pattern matching is one of the most important concepts too, because we can use conditionals or loops inside of the functional code. So if we can use conditional or loops, how we can determine which type of value are going to return or use in your own logic. Haskell provides the pattern matching. I read that C++ was with the intention to implement pattern matching. It's not native, but we can try to reproduce the same logic with the std variant and std visit. For example, we have 3 types of cherry pans based of which type of cherry pan we pass to the function describe cherry pan. We are going to return a string with the description of that cherry pan. So how we can use this on C++? Well, we need to declare some struct to indicate which type of cherry pan we are going to use. And using the std variant, which is a safe union, declare which cherry pan could be any of 3 cases. Later, we declare the function that receives as argument this variant, and using the std visit, we can iterate over this variable and determine if the type of the variable is one of the conditions and return the appropriate description of this cherry pan. Pattern matching is very important, and we can see that the correlation between Haskell and C++ is easy to follow. But
excuse me?
see, yes, please tell me.
How is using a variant better than overloading in terms of pattern matching?
Overloading in the visit pattern?
No, I mean just 4 different functions with 4 different signatures overloaded.
It could be another way to overload the function signature, but we are using the one signature to iterate over any possible case of the pattern matching.
Okay, we have one other question.
It's basically the same question. It was basically the same question. So, as in, why would we want to follow this pattern, or I guess, what is the strength of following the more functional programming style, rather than saying, let's have polymorphic runtime, or as it was explained, just an overloaded function? What would be the advantage of this one?
It depends on the problem to solve. Always paradigms of us weakness and strengths, but always depends of the solution of want to implement that you want to implement. Functional programming sometimes has a better performance when we use concurrency, for example, because the immutability of the information allows us to avoid race condition. That object-oriented programming is, we need to use mutex and protect the critical section. I think it's always depends of the design of the solution of you want to apply. These are possible a very simple way to translate some of the concepts of Haskell to C++. Sometimes we can improve it, of course. And with, for example, with the use of the object-oriented programming, if we have to overload or using virtual function, we are using a lot of virtual tables, and virtual tables are not cheap, unfortunately. And that could produce a lower performance. Any other question? Please interrupt me if you want. I hope I can answer all your questions. And okay, let's continue. Another way to this pattern matching is easy to see, but the lazy evaluation, which is the way of Haskell to evaluate the value of its variable, is not. Pattern matching and lazy evaluation is not a native C++ way, but we can try to reproduce the same behavior using an object. In this case, we are using an object to represent a functional concept. For example, here we are declaring a list of string, and the function repeat will make a copy of my string, and take will be select the first 5 position, and we can always taking this in the loop. When we use the lazy evaluation in C++, we need to declare a class template object that allows us to specify which type of calculation we want to store, and using a cache way, return the value of this object once it's created, or create a new value if it's the first time we call it. So we declare an optional value, which is the safe ways of declare if the variable has a valid value or not. We see it was introduced in the 17 standard, I think. And we can protect, if we are using a multi-threading programming, this way of initialize that cached value with the mutex. So we had our constructor and a function make evaluation that result this forwarding or computation, but the operator, function operator here is the important part, because we are locking the mutex, protecting our critical section, as if the first time we are calling our function, we are creating that cache value, we invoke and create it. If not, we are always returning the previous calculation and avoiding to perform a new one. And we have in this example that we are declaring this lazy evaluation once. This is the creation, and we call it again. We are using the catch value. And I added this slide in based on previous comment. That is the list of compression. Like I say, we are in functional programming, we are not able to use conditional or loop. So how we can iterate over a list and apply a logic to the list. So we are in Haskell, we have the list compression that are a way to declare a list or a vector, or maybe if you want an array of element, and apply a logic for each element of this array. We have squares here that we are applying the logic of prods by self the number to a list of 1 to 5. We can even more take a filter of that list that only returns even values. And this way is easy to see with C++ because we have the range and the concepts, the range and the view. For example, we have this code here, which we have a vector price and the associated choripans. And we are transforming here in the iteration, making a pair that is the result price by the tags and the associated choripan. And we are making a zip value. We are taking 2 arguments and associate as 1. And from this list that have 3 values, we are taking only 1. Please take notice we are not using any for loop for this function here. And we are only using a pipes operator and a functional approach. There is not a explicit way of how we can iterate over the vector, at how we can calculate or make the pairs or the details. Only focus on what we want. We want the first price of the association between the choripan and the price, and with the value calculated with tags. Only thing. Unfortunately, this way world of the functional programming is very huge, and we had to stay all night here to talk about all the concepts, for example, monads. Probably we need to reproduce the Lord of the Ring theology, which to talk about all functional way. But here I left you some nice video that I find in internet, the ACO conference. Another is the CPP-Con from template to concept. And if you have any question, I feel free to ask them. Thank you so much for the time. I hope you enjoyed this talk as much I enjoy to give you. Thank you.